All right, so in this question, we have a laser beam shining in the air and entering a fish tank filled with water. The light strikes the water surface at an angle of 30 degrees with the normal to the boundary. The index of refraction for air is given as 1.00, and for the water, the index of refraction is given as 1.33. And we're asked to find the angle of refraction, which is the angle the refracted ray makes with the normal. Now, we want to start with the sketch for these questions, and for that we're going to need a ruler, and I'm going to start by drawing my boundary. Here's my boundary, and our light ray is coming from air and it's entering water, so let's label that. Let's also label our normal. Our normal is a perpendicular dashed line to the boundary, like so. We're going to label this normal. Let's also label which medium is faster and which one is slower. Well, light travels faster in air. So I'm going to label this fast. I'm going to label this slow. Relatively speaking, light travels slower in water. Okay, now we're going to draw our incident ray. And we know the incident ray makes an angle of 30 degrees with the normal. So we don't need to use a protractor for these questions. They're just sketches. So I can still estimate, however. I can still estimate that, this is 45 degrees. So that means this must be around 30 degrees. And that's acceptable. So let's draw our incident ray here. And if this incident ray was to cross, if there was no boundary here, well, we know the incident ray would just continue along like this. So I'm going to indicate that with a dashed line here. All right, let's label the angle. The angle was 30 degrees from the normal, so that here is 30 degrees. And let's also indicate the direction of the ray. It's coming from air, going into water. Okay, now we know that when light is traveling from a fast medium or a medium where it travels faster to a medium where it travels slower, the refracted ray is going to bend towards the normal. So it's going to come closer to the normal. And it's the opposite if it was coming from a medium where it's traveling slower to a medium where it's traveling faster. If that was the case, then it would be bending away from the normal. So in our case, it's the first case, so it's going to bend towards the normal. We're going from a medium where it travels faster to a medium where it travels slower. Okay, and let's mark the angle here. Now it should be a smaller angle compared to 30. Okay, how do we prove that mathematically though? Well, let's use grasp, right? We've practiced with grasp from before. Let's keep that up. So grasp, start with your givens. My givens, well, we know the index of refraction for air is 1.00. And if we can also label that on our diagram like this. We know the index of refraction for water is 1.33. We can label that over here as well. We know the angle of incidence is 30 degrees. That's theta 1. That's 30 degrees. Okay. What is our required? Well, that's the angle of refraction, theta 2. What is the equation we're going to use? That's Snell's law, which is n1 sine theta 1 equals n2 sine theta 2. We're going to isolate for what we're looking for. And what is it we're looking for? We're looking for theta 2, the angle of refraction. So I'm going to divide n2 on both sides. And that's going to leave us with this on the left-hand side. And this on the right-hand side. What's next? Well, we got the sine here. I want to get rid of that sine. I could take sine inverse. Sine inverse on both sides. Oops. That should be a 1. And 1 sine, that should also be a 1, sorry, over n2 equals theta 2. Okay. Now we can move on to the S step, substitute or solve. Well, sine inverse 1, we know n1 is 1.33. sine of theta 1. Theta 1 was 30, so I'm going to substitute 30 degrees over n2. n2 was given as 1. Oh, I'm sorry, I made another mistake here. n1 is in fact your 1.00. Mistakes like these happen as you're solving these types of problems. That's fine. Just go back and correct yourself. 1.00 sine 30 divided by n2, which is 1.33. Okay, that equals theta 2. I'm going to continue over here. So theta 2, I'm going to flip it. I'm just going to flip it. I'm going to put theta 2 on the left-hand side of the equal sign. I'm going to put the rest on the right-hand side, but I can just simplify this in my calculator. Here's my calculator. Okay, so sine inverse fraction 1.00 sine 30, brackets closed, over 1.33, brackets closed. I got 22.08. Let's round that to 1 decimal place. So 22.1 degrees. And let's paraphrase. The last step in grasp. So we can say the angle of refraction is 22.1 degrees. And that's it. All right. Thank you for listening.